Hello friends, welcome to your only channel Times of Coding. Today in our series is Scala Express, we will learn about test frameworks. This session will help you to understand different style of test cases writing while feature and function validation. In previous session we have learned about implicit imports, access modifiers, access qualifiers, companion object and package object. In this session we will learn how to write JUnit test cases, how to use function suites test, how to write test cases in BDD style, how to use feature specification test framework, and how to do property based testing. When we write code in any language, to check behavior of software, we often write test cases. Some test cases we will see in this session also. And to understand that, first we will see the example of assertion. So here I'm defining one class called mathematics. Inside that mathematics class, I'm defining divide number and multiply two numbers. In these two functions, I'm having two parameters here, numerator and denominator, and then two parameters here as first and second. Int will be the return type of these functions, and here we are performing division, and in this method we are performing multiplication. Now I'm having one flag counter just to count the number of functions inside that mathematics class. Since we have defined two functions, so I'm keeping two here. And this is how our usual class look like. In order to validate the functionality of this class, we need to write some test cases. Now these test cases I will write with the help of JUnits API. When we will do practical, I will tell you which Maven package we need to import in order to get the JUnits API, but for time being, you can treat like these APIs already enabled in our module. So moving on to this test case. This test case would be a type of class and it could have suffix as test or spec. Spec is basically for specification and test for testing. So above we have defined mathematics class and here we are defining mathematics test. So in that we are defining three variables here: expect divide, expected multiply, and object math. Object math will get the object from mathematics class. And this is the first definition of test cases we are writing here. As per JUnit framework, we need to declare our test cases with org JUnit test. In that case, compiler will understand that these are the test cases definitions. So first we are testing the divide method. Here we are having one actual value. This actual we will get when we call the divide num denominator function. So this object math will help us to get the function call here, and then we are passing two arguments as 40 and 4. So result of this function will get stored in actual. Then we are having assert. Assert is basically to check the equality we are using here, and then we are passing the expected divide. Expected divide is the 10 which we have defined earlier, and then we are giving the actuals which is coming from this function call. And likewise we are doing for multiplication also. If you see, expect multiply we are having here as 10, and then here also we are passing 2 and 5, so actual will be 10. So that's how we write test cases while using JUnit API. Now here one more sample test cases I have defined, which I will let you to explore till we do the practical. Okay, so Scala does not only support JUnit, it has other framework support as well. So moving on, we will explore some more frameworks also which we can use while writing Scala test cases. So here I am using fun suite. This fun stands for functions basically. So it's a function suite to do the testing. And here we are defining class called mathematics suite. And the way this function suite works is little functional type. So first we are defining human readable test cases condition that mathematics number of function values should be 2. And here we are using the same assert. We are calling out the object of mathematics class so that we can call number of functions. Whatever value it will get us, we will compare with 2. If this matches, it will hold true here and this test case will get passed. If you observe, this is kind of functional style, and with JUnit which we have seen earlier, it was imperative. And since it is an imperative, it was having boilerplate code also, which you can see here we are avoiding. So underlined logic is just to validate the functions only. But these styles of writing your test cases can give you little flexibility. If you're coming from imperative, you can use JUnits. If you're coming from functional background, you can use any suits which suits to your background languages. What if we wanted to add some more information while test case is failure? That we will do now. So here I'm defining one val count is equal to 3, and then we are testing this count is equal to 4. So here, since this is 3, this condition will fail. We have got few more examples here. So here we are having assert. Inside that assert, we are having list of 1, 2, and 3. And in that 1, 2, and 3 list, we are checking for 9. So obviously this will also get failed. And the message we will get after failure is did not contain 9. So here also we are passing assert result. And inside that assert result, we are keeping 4. And then we are writing, since count is 3 here, this will also get failed. Because the expected value is 4, but what we have got is 3. So likewise exception you will get here if you write your assert statements like this. I'm explaining very limited functionality of assert here. It has got many functions which you can explore. And if you see in this example, we are having assert throws. That means in case of exception also, you can have a match. So here I'm passing assert throws of arithmetic exception type. And inside this curly braces, I'm doing 4 divided by 0. So in that case, it should throw the arithmetic exception. And when we execute, it will match. That means it will succeed it. So a test case basically will succeed if you write this statement, but eventually you are catching the exception, which has got raised from here. So in fact, likewise scenarios, we will have a failure and we will not be having much control on the information which we receive after test failure. Because these messages are standard messages which are coming out from Scala packages APIs. But we can add more information in our assert statements while having an equality check for these messages also. So here I'm having one equality check for arithmetic exception message, and here I'm defining /by0. And when we expect some statement to throw some error or exception, we can compare their message as well, like the way I'm doing here. And in that case also your assertion will get successful and your test case will get passed. So now next thing is we will see how to write test cases specification style of writing. Usually we follow this kind of style in BDD type development. BDD is behavior driven development I'm talking here. According to this style of writing test cases, it is more human readable because we are articulating our functional technical checks. And now we will see how. So here I'm defining one class called element spec. With suffix spec, that means we are defining a test class here. And here I'm extending flat spec with matchers. So first we need to define a test case specification, and that is a mathematics should have a number of functions equal to the past value. Our past value is 2 here, which I'm by default keeping. And then we are creating one object of mathematics class. And then we are calling number of functions. And the outcome which we will get out of this number of functions, we are comparing with 2. So it should be true.
Then we are adding 2 more conditions in this test case, which is it should have a division function resulted as past value. And we are passing 2. Here we are creating object of mathematics class. And then we are giving a call to divide function with 10 and 5 as argument. After this, we are defining throw an arithmetic exception if passed as 0 as argument for division function. So to capture this, here we are writing an arithmetic exception should be thrown by object of mathematics. We are calling divide num then function with 10 and 0 argument. The actual execution result we will see when we do practical. So if you notice, our previous example was little imperative style of coding with the help of JUnit framework, and here we are using flat spec with matchers. Now in this style of writing test cases, we are relating our technical checks with functional style, and that's what we call as behavior driven development style of testing. Likewise, we are having another framework called feature spec. So in this feature spec, we will write our test cases like feature, we will define a feature here like perform divide operation, and inside these features we need to write the scenarios. So here I'm defining one scenario, and then we will write given, when, and then statements. With this given, when, and then statements, we will keep a condition and then must have some equality check here, like the way we are doing for asset. So again, we are creating same class object, calling divide function, and then we are having an equality check on functions result. And then we are having AND condition also if we have got some post check in this scenario. And then I'm keeping closure message. Now we have written our test cases like this in a BDD or functional way, and I have assumed that our implementation has been completed. Now if you are into requirement discussion and you wanted to write some feature specification just to showcase stakeholders, you can keep a pending here. When you write pending after your given, when, and then statements, that means implementation of these features is pending. Okay, so our next example was property specification. In order to write property specification test cases, I'm extending this mathematics class with function called operation. And in this operation, I'm keeping array of string type, and I'm defining few operations we usually perform in day-to-day life. Okay, so coming to our test cases, here I'm defining class mathspec extend prop spec with table driven property checks. This table driven property, if you are having some table requirement, you can define it, and then I'm mixing given, when, and then. So right now in this example I have not kept any table, so we can treat this as optional. Okay, so coming back to here, defining same object. Now we need to start writing our test cases by property tag. So inside that property function, I'm giving a message to this property. A division operation could be performed from mathematics, and then we are having operation as collection, so I'm keeping for each to iterate over all the elements. And now I'm keeping operations for this iterative elements, and then we are writing given, when, and then. Here I'm having a result is equal to 10 with divide and num functions, and we are calling divide and num functions with the help of 10 and 4 as argument. And before calling this function, in fact we have got precondition also, which is operation is empty. Since we are having exclamation here, so it is operation is not empty, which is true again. So with this example we have covered today's content. Now it's time to do some practical. Okay, so our IntelliJ started. Now first thing, we will observe our build.svd file. So here we are keeping 3 library. One is for JUnit, and version we are using 4.11. Next one is scala.test, and the version we are using here is 3.1.2. And the next one is spec2, and the version we are using here is 4.9.0. In my content, I have kept most of the example by using these 3 library packages API only. And one more thing here to notice, my Scala version is 2.13. That's why you might have seen some depreciation messages while writing code. But most of the examples are relevant to 2.12 version. So if you are using 2.12 version of Scala, you will not see any depreciation. You might see in my example because my Scala version is little higher. Okay. Now I'll come back to the hierarchy. So yet we have defined everything inside the main.scala package only. And here we have got our whole implementation. But when it comes to test cases, we will not use Scala package. Instead, we will use test.scala package. And inside the test.scala, we will define our test cases inside the Scala package only. Okay. So the first example which we have seen today is our mathematic class. So first, I'm defining here mathematics class. And inside that, I'm defining divide and multiply function, numerator and denominator as parameter, first and second parameter for multiply function. The type of these functions I'm keeping as int. And then here, I'm defining numerator divide by denominator, first multiply by second number. The number of functions variable I'm keeping 2. And for operations type, I'm keeping array of string. And inside that array, I'm defining few operations type. So this was about our mathematics class. And now we will write test cases to validate this class functionality. So as I told you earlier, we need to create one package called com.scala express.testing. Inside that package, the first example which we have seen today is our mathematics test. And this example we are writing with the help of JUnit suite. So here I'm defining mathematics test and then local variable expected divide and expected multiply, and then I'm creating one object for mathematics class. As per JUnit framework agreement, when we define test cases, we need to keep one annotation also, and this annotation is @org.junit.test. Now in this test case, we are validating divide function. With the help of object method, I'm calling divide function, and inside that I'm passing 40 and 4 as argument. Now the expected divide value we have already defined. With the help of assert, we will have an equality check between actual, which is coming from this function call, and the expected divide. Likewise, I'm doing for multiply, and then I'm writing one func test also, which is having a check on number of functions. Now one thing to notice here, in these above two test cases we were using assert, and here we are using ensuring. So this is also one of the method which we can write in order to do the equality check. So in this example, we have seen how to write our test cases in imperative style. Now our next framework was fun suite. Fun here is for functions, and this framework will give you outlook of functional style of writing test cases. Now here we need to start writing our class name as suite, extending fun suite, and then we will keep a test case condition here. So first I'm defining mathematics number of function value should have 2, and then I'm having assert, which will have a equality check between number of functions and 2. If I run this function, test case passed. So this is the expected outcome. And previous example also, let's run it. Mathematics class, right click and run. And here 3 of the functions have passed. And if you see the total count, you might have many test cases. You can see the count here. 3 of 3 test. Now after fun suite, we have talked about few failure scenarios. In order to understand those failure scenarios, we need to open our informative failure worksheet. So here I'm defining few of the examples. Like first I'm keeping val count is equal to 3, and then I'm keeping equality count is equal to 4. This will obviously fail, but we need to understand the error now. So for time being, I'll make this all commented. Okay, let's run. So when this get failed, you will get a exception like test case exception, test failed exception, 3 did not equal to 4. So in the test cases information, when it get failed, first we receive the type, and then we receive the error message, and then we receive the stack trace. This is the format our failure message comes. Now it's time to have a look on one more. So here I'm using list type of collection, and then we are checking contains 9, where this list has been defined with 1, 2 and 3. So I'll comment this. If you see, this is the type of exception, and this is the message of exception. So list 1, 2 and 3 did not contain 9 as we expected. So moving on, we will have another example. So in this assert result, we can define a result at front, and then we can have some value or some logic which will get executed and produce this result. So now I will execute, and as you can see now, expected value was 4 but got 3. Now likewise I'm keeping for exception also here, and then I'm having one informative failure on message. As I told you, this part of the exception is message, so we will run that example also. Now first I'll execute, and then I'll go through one after another. So here we expected that this statement will raise some exception, and we were having assert throws of type arithmetic exception, and since this statement has given arithmetic type of exception only, our statement will get succeeded. Now coming down to this example, here also we are having similar, but instead of assert throw, we are intercepting this, and intercept result we are storing in error type. So if you do likewise, you can have a get message also out of this, and with this get message you can have your equality check whether it has been divided by 0 in case of arithmetic exception, or maybe some other message relevant to your exception. So when we run this, it was having this message with this type, and here we have got hold of type, and with get message we are getting hold of this message also, and then we are having a check here. So our test case should technically get succeeded. So moving on, after this example we have discussed mathematics spec. Now this style of writing test cases will give you a functional feel, because usually we write test cases like this in BDD style, which we have seen in earlier also in FunSuite type of framework. So here I'm defining one test case spec, extending flat spec here with matchers. Now when we write with these APIs, first we need to define the specification. A mathematics should have a number of functions equal to the past value. So this is our test case specification. And then we are having, with the help of should, we are writing more scenarios here. So here we are creating one object, and on that object we are calling number of functions. And then we are matching up this number of functions should be equal to 2. Likewise, we are doing for divide function. We are calling divide function with 10 and 5, and we are matching up should be 2. And then we are expecting one arithmetic exception if passed 0 as argument here. And likewise, we are passing here also. So when I run this example, okay, whole 3 test cases got passed. So this is the example of our flat spec, which is again a kind of BDD style of writing test cases. If you see, it was also focused on the functional features, and it was very human readable language, and we have used human readable language in this test cases. Now on the same topic, we have got another framework also called feature spec. In this feature spec, we will write a test cases like two humans can have a conversation among themselves. So first we will be defining a feature, and then in that we will be defining a scenarios, and with the help of given, when, and then we will be writing our conditions. And if our scenario is having some post check also, we can include as end, and then we can have some closure message here. So this feature spec we are using with combination of given, when, and then, and that's how we are defining a test cases class. While writing feature spec, first we need to define the feature. So perform divide operation is our feature. Then we are defining one scenario. So first we'll create the mathematic class, a call to divide num function. So this is one of the scenario. And then we are calling when. So when numerator is 40 and denominator is 4, we are taking a result, and then result will be 10. So here we are running an equality check, and after this equality check we are having one extended scenario condition. Mathematic class should have 2 number of functions. So here also we are having number of functions equality check, and then closure message. Now it's time to run this test class. Okay, so our one test case passed, that means our feature passed, and whatever information we have kept given, when, and then you will get to see. So here, given a call to divide num functions, when numerator is 40 and denominator is 5, then result will be 10. And mathematic class should have 2 number of functions. Mathematic class test completed. Now if you see, the outcome of this test execution was helping users to understand what is going on, and it is a functional style of writing test cases, which usually come in features validation. So normally BAs, the business analyst, do this kind of testing to validate the feature requirement. They might write these kind of test cases in requirement gathering, or maybe to present these features definition to stakeholders. Now moving on, we are having the property spec. This property spec these days mostly used by data engineers, because here we generally talk about the iteration. Now if you see, we have defined operations which was having addition, subtraction, and likewise operations in our class, and these operations we are applying for each here, and inside that for each operation which will hold the iterative value from this operation collection, we are using the same given, when, and then. And likewise we are doing a precondition check here. Operation is not empty because we are using exclamation here, and then we are calling divide function, and then we are having a equality check. To write our functions in such way, we need to extend prop spec with given, when, and then. And when we write property specification, we need to define property first, and then we need to write our test cases inside those curly braces. Now we will run this example, and here our test case 1 has got passed, and we will see it has numbers of iterative information. Given a mathematic class, operation should not be empty. When calling divide num function with 40 as numerator and 4 as denominator, it should give 10. So In our operations, we have defined 5 types of operation. So this must have reiterative 5. So let's count 1, 2, 3, 4 and 5. Now let's suppose if you are a data engineer and you wanted to validate some information which is coming from one big file, and this file is supposed to have millions of rows. So you can write property based testing, and you can think about streaming data, the IoT kind of applications where your data is keep coming and you wanted to validate the data. So in these cases, you can have your property specification style of writing test cases. Now with this example, we have completed today's content. In today's session, we have covered JUnit test, function suite test, BDD style of testing, feature specification test, property specification based testing. I hope you liked today's session. Thank you. Have a good day.